Cool. So today I'm going to talk a little bit about web performance and the future of web performance as I've kind of seen it. So this is going to be a highly opinionated talk. This is going to be a talk mostly full of things that I believe strongly, and I also hold them to be 100% true. So start with a little bit about me. I am a senior dev front-end architect. I currently work as a developer advocate at Gatsby. Do a little bit of design sometimes. I've also known to write books and articles, talk about stuff every once in a while. Really big on process and efficiency to the point that that's typically what I talk about. You know, talking about dev is not usually what I do. I usually talk more about how to be good at dev, like good teams, like that. But today I'm going to be talking about Gatsby, but not really about Gatsby. I'm actually going to be talking about web performance in general, and then I'll loop it back around to Gatsby. This is where I work. Gatsby, for those of you who have not tried it or heard about it, is a front-end framework. You build React sites. We build super fast sites out the other end. They're all static files, cheap, free to host, et cetera, et cetera. So let's go through. We're going to do an incomplete and heavily biased history of the internet. History of the internet is very long, and most of it has nothing to do with what I'm going to talk about, so I'm going to skip all of that. So in the beginning of the internet, there was HTML. And HTML was wonderful because you just got to say, I want something on the internet, and then you wrote something in a text file, and then it was on the internet. It was just magical, right? And it allowed us to do things like this. This is a GeoCities website, and I found a Tumblr that just posts archived shots of GeoCities websites, and this wasn't even the best one. But this was great. This was like a superpower. You know, in my case, I was a kid, right? So suddenly, I had the ability to just, like, for cheap or for free, in my case, free, I could put something up on the internet. And I could share it with strangers, and I was connecting with people around the world, and I was seeing what people who weren't in my high school were doing with their spare time, which unfortunately was exactly what all of my friends were doing with their spare time as well. So it was kind of disappointing as a teenager to see that, oh yeah, all teenagers are idiots. It was also supported nearly everywhere. I mean, I have to say nearly because I'm sure there were some browsers that didn't support HTML, but I never used them. I think that for the length of my career as a human on the internet, HTML has always worked. There were very few requests to display something on a page. Typically speaking, your HTML page was the request. You said, I would like this HTML page, please, and the server said, here you go, and that was the end of the transaction. There were no CSS. CSS didn't work. JavaScript was so hard that nobody wrote any. It was, you know, you'd maybe have an image, and if there was an image, probably that loaded like line by line, very slowly. So typically you wouldn't do that, right? You would do something else like a marquee. And typically that resulted in a small file size. So you weren't sending a lot of data, you know, 2 kilobytes, because too long to send anything else. However, there were a lot of shortcomings here. So typically writing an HTML site resulted in a lot of copy-pasted. You were, you know, doing lists, or you were doing divs, or you were doing, you know, in my case, just lots and lots of nested tables, which meant that you were copy-pasting things constantly because you didn't really want to write all that by hand every time. And that resulted in a handful of issues. My favorite of which was in my notepad.exe trying to hunt for the one tag that I hadn't closed. But there was no such thing as dry. Every piece of code had to be manually transplanted from place to place. If you had a multi-page website, probably 90% of the HTML on the site was going to be duplicated on every page because your header, your navigation, your footer, all of that had to be copied from file to file to file. That's a pain. So this all kind of resulted in a pretty terrible developer experience. On a small site, this is no problem. My hobby site as a teenager, where I had like a fan page for whatever metal band I was into, it only had 2 pages. So if I made a change, I just made that change twice. But if you were running a professional website with hundreds or thousands of pages, making those changes was an enormous undertaking. It took a ton of time, and you always screwed it up. And there would inevitably be just like whole chunks of websites that you could tell nobody cared enough to go and maintain because they'd be showing like the previous design. So in professional use, it just really wasn't doing the job, right? So as a community, developers just kind of said like, we're not going to stop there. We've got to do more. So PHP happened, right? And so PHP was a pretty wonderful thing. For those of you who are, sorry, I should have said trigger warning. I'm showing WordPress code. This is pretty powerful stuff though, because what you're looking at here, hold on, I'm gonna try my magic thing that I was showing you here. See if this works. Can I do it? Will it work over here? Totally doesn't. It's fine. I got this cool thing that'll show a spotlight on the screen and it doesn't work. So over here, we've got one function that loads in the entire header. We've got a loop that creates the post. We've got one function that loads in the entire footer. This means that suddenly our code is drier. We can edit the header in one place and have it update across the entire site. This is really cool. So let's talk about that. A lot of ways this was great. We had separation of concerns. We wrote code in one place, the way that things should look. We had our data in another place. Really good thing. We had code reusability. You know, like I said, we were able to drop our header into one file and reuse that everywhere throughout the site. We had the ability to dynamically manipulate data. If somebody submitted something through our website, we were able to do things like sanitize that input. We were able to check for like copyright dates and make sure that we'd updated them to this year or whatever other, add a counter to your website, which was clearly the only reason that you needed dynamic data manipulation. But in other ways, it sucked. Servers are expensive. Instead of having a free GeoCity site, you're now paying somewhere between $5 and $50 to $500 a month for a server, depending on how heavy your app is. You need special hosting. Your host needs to support the language that you use. So if you wrote it in PHP, you need PHP hosting. If you wrote it in .NET, you need .NET hosting. There were things that suddenly you needed to know. And scaling those services is hard because it wasn't just like, oh, I'll buy more servers. You needed to buy more servers, but then you needed to put like varnish in front of it. You needed like edge caching, and you needed to understand how all of that worked, which I never did, which meant that if a lot of people came to my websites, they just crashed. And that added a lot of complexity, right? So this was something that it was a huge leap forward, but it still just wasn't quite there. We still had a little ways to go. So we as a community, and I'm assuming all of you are guilty of this, so just stick with me. We're all like hive mind today. We moved on to client-side rendering. This is Mustache. Mustache gave us a lot of the same abilities. It's very familiar to the WordPress code. So you've got a loop. Inside that loop, you're pulling in dynamic data. You're pulling in your title. You're pulling in your body. And super cool, right? Same thing with the headers and footers. You could do the same thing. You probably wouldn't client-side code, but hey, we didn't know better. And in a lot of ways, again, this was great because we got most of the benefits of server-side rendering. A lot of what we wanted was the ability to reuse our code and share things around and get that data manipulation, all that good stuff. But it removed something. It allowed us to get rid of those special servers. We could go back to hosting with server-side rendering. And it gave us additional opportunities for interactive UIs. When you start using JavaScript or front-end templating, suddenly you can do things. You can have tabs, you can have carousels, you can have popovers and modals, like kind of started changing the game. Things like jQuery came in and allowed us to do a lot of really powerful, really interesting stuff. And again, that also kind of sucked because now we're spending a bunch of extra requests to load jQuery, to load Scriptaculous or MooTools or whatever the thing was that we were using. We had these like tricky error-prone interactions because everything was kind of hand-coded or copy-pasted from a tutorial. It was all polluting the global namespace. We were extending prototypes. It was a nightmare, right? It was the Wild West. Nobody knew how this stuff worked. And so we just made it up, right? Which meant, we had things like W3 Schools, which was kind of famous I don't know if they fixed it now, but it was famous at the time for just having utterly terrible advice because they didn't understand it any better than anybody else did. And in order to make these work, you needed to have JavaScript enabled, right? There was no option. If JavaScript wasn't enabled, your site broke. So it just still wasn't enough. We still weren't happy. or ironically, we were using a lot of papyrus at the era of the internet. Those of you who didn't get that joke, you should go Google papyrus and Ryan Gosling. So, as JavaScript developers are wont to do, we doubled down on client-side rendering when client-side rendering wasn't working. And so React happened, right? And now React adds all of this kind of virtual DOM and all these performance things. Now you've got like trees, and there's a lot of forestry. I don't know exactly how all of it worked, but suddenly we had a lot of extra flexibility here. This is super cool because now, instead of us loading a bunch of things into the global namespace, we're doing our client-side rendering in a very contained and predictable and well-documented way. So we go from this kind of Wild West approach, copy paste whatever you find on the internet. Now we've got like a pretty decent approach to doing things in a predictable, shareable way. So this is amazing, right? This gives us a lot of really powerful things. We're running our full-on apps in JavaScript, and because the API of front-end frameworks like Angular and React and Ember and Backbone, they were predictable enough that you could build things that could be worked on by a team. They were scalable. They would actually function. It suddenly made JavaScript a viable option for enterprise code. That's a huge leap forward in the front-end world. Because prior to that, if you built something in JavaScript, like you could do it if your front-end team was really like experienced and willing to put up with a lot of nonsense, and maybe they like were wearing golden handcuffs so they could never leave. There were a lot of ways to make it work, but typically nobody could afford them. So React and its the Angular stuff before that made it suddenly possible to legitimately look at JavaScript as a viable option for running your website. And that's great because it allowed us to start looking at mobile experiences as a viable replacement for native development, or not as an alternative, not as a replacement. Now, interactivity is incredibly approachable. We've got, through synthetic events, we were able to kind of unify the experience of handling events across different browsers. We got rid of a lot of browser incompatibilities through frameworks like React and Angular. And the community and ecosystem is extensive. So now when I need a carousel, I just install React Carousel. When I need a modal, I just install React Modal. I don't have to reinvent these wheels anymore, and I'm not even having to copy paste. So now when somebody updates this stuff, I just update my dependencies. I don't have to like go figure out that it changed and copy paste that code back in. It just works, right? This is magical. And all that leads to an incredibly good developer experience. But again, there are still things about it that suck. One of the things that really sucks about this is that we're sending a ton of JavaScript to the browser. I didn't get a screenshot of it because it makes me weep when I have to look at it, but I left my browser open for about 30 minutes on, I think it was CNN.com, and it sent me 10 megabytes just of JavaScript. It made 2,000 requests, right? Sorry, I'm getting choked up just thinking about it. And then, of course, we still need JavaScript to be enabled. Like, we're still putting a really negative experience out there for people who don't have JavaScript devices. Our pages are loading slower and slower and slower. And that's a really bad thing because more and more and more people are going on to mobile, and more people around the world are coming online. And a lot of those people are on 2G networks, which means it takes them upwards of a minute to load a web page. And that is not acceptable as an experience. So while a lot of times we're sitting here looking at React like, yeah, guys, we solved the internet. We figured out all the problems. Everybody kick back, put your feet up, we're done. But I think we may have celebrated a little bit too early. That poor guy. No one will remember anything about him except this GIF. So let's talk a little bit about where we are today. That's kind of like the history bringing us up to now. So where we are now is that our JavaScript frameworks are incredibly powerful. They can do things that we've never seen possible in the internet or on the front end, and they're starting to reach into the back end. Suddenly we can use React on native applications. We're seeing the ability to basically write React code and deploy that anywhere. Any target that we can think of, probably there's a way to write React for that. That's an incredible leap forward, but still super expensive. We are slow because we're asynchronously loading data, or we're synchronously loading data, which is blocking the page render altogether. We're sending down huge bundles that take forever to download. And then once we get them down there, parsing that JavaScript, like 1 megabyte of JavaScript on it, like an iPhone 4 takes multiple seconds. Like this is an incredibly unwieldy way to manage JavaScript, is to just say, oh, well, one bundle is fine. Let's send them 3 megabytes of JavaScript. You're pushing back your load times by 15 seconds when you do that on an older phone. And they're all still JavaScript dependent, right? You need a way to get around that, because if your stuff doesn't load with JavaScript, you've got, not so much anymore, but search engine issues. You've got issues with, again, people on slower connections who just aren't able to support JavaScript. They just can't use your websites. And I don't know if anybody's been to, has anybody been to Europe recently since GDPR? No? Okay, so over in Europe right now, a lot of websites, you go there and it just says, sorry, you can't use this because we don't know how GDPR works. Like they just turn you away from their website. When you send a 3 megabyte bundle down to somebody in Africa, you're doing exactly the same thing. That site will never load. And if it does load, it's not going to work properly. So we have to do better, right? And if you're in, like, sure, that's cool, whatever, out in the internet, like doing good for the world. But right here, right now, in first world, in the United States, if your website takes longer than 3 seconds to load on a mobile device, half of your visitors will leave. Mobile traffic crossed 50% last year. That means that if you have a site that takes longer than 3 seconds to load on mobile, 1 in 4 people who may have bought something from you are abandoning your website before it ever loads. That is not a viable business. So performance is more important than it's ever been before, because we kind of sort of fixed responsive, right? Like that's sort of a solved problem. Frameworks are there. We've got to the point where now people at least know how to show something on a mobile phone, but the average website on 3G is taking 15 seconds to load. That's not really a viable way of doing it. It's not a solve. It's not a sustainable way to operate enterprise level businesses. You need to be able to get something on the screen in a way that's going to get somebody to engage with it. So let's talk about ways that we can fix this, right? So to make really fast JavaScript apps, there are a few things that we can do. One of the easiest things, what the hell happened here? Wait, for real though. My slides went out of sync. Just do, let's do these. Oh God. Oh my God, I'm not even looking at local slides. I'm looking at, second. Doing great, thank you. Let's just hop right on over here. It's gonna be so good. Just stick with me. So all of this really fast. This is a recap that we've got context going into the next section. So to make our JavaScript apps really fast, what we need to do is get my speaker notes back up. Nobody look at these. We need to go this way. And then I'll look at this. And now we're back on track, everybody. Okay, so, no, keep it in. So we need to implement our route-based code splitting, right? So route-based code splitting, I'll talk a little bit about each of these in detail going forward. We also need to use HTTP2 to serve assets. I'm not gonna say that anymore because I'm definitely gonna get it wrong. We need to set up background prefetching. We're gonna lazy load any non-critical assets. You may have heard this referred to as the purple pattern. This is a gentleman named Adi Osmani. He works on the Google I don't know, he works for Google somewhere, talks a lot about performance. Very, very smart man. And they kind of popularized this pattern that they call purple, which stands for push, render, pre-cache, and lazy load. And what that means, when we take this back over here, is that we're implementing route-based code splitting, which means that, well, we're going to talk about that more in a second. But so the pushing is using HTTP2. What that allows us to do is some really, really cool, powerful stuff. Pre-caching means that we're trying to get things when the user doesn't need them, so that they're able to see what's on, or they're able to get to things quickly as if they loaded fast, even if they didn't, but they happen in the background so nobody knows. And then lazy loading means that we get things only when they're needed, which might sound like it's at odds with pre-caching. We'll talk a little bit about what the difference is here in a second. But the purple pattern isn't enough on its own. There are other things that we need to do. So a couple things that you can do to improve your performance is add a service worker. Eliminate all of your unused code, which is a big one, especially when you start using third-party tools, because they ship a lot of code. We probably only use 1 to 5% of it in the average app. So make sure you're not shipping that to your browser, to your users. And use server-side rendering to generate static files. And we're going to talk a little bit more about that later on. But for now, I imagine a couple people are thinking, that's too many things. And I kind of agree with you. It's hard. So let's talk about a few of these in sequence here. So let's start by talking about service workers. At bottom, what service workers are capable of doing is installing something that will create a cache on the browser. So this is in the browser, and it will do something like add a bunch of assets to this cache, this my site v1. And these are non-blocking. So these can load whenever they're ready to load. These ones, however, have to load before the page can load. So typically the way you would do that is the stuff that's in the critical path would be your header, your footer, your required JavaScript, your style sheets, things like that. And the non-critical stuff would be if you've got something that's going to load inside of a modal, if you've got fallback images or maybe like a second page, those are good things to load in the background because I don't need the second page worth of assets before I load the first page. But it is really nice to have those ready to go. So that's kind of like a really high level. There's service workers do a lot of things beyond that. This link, the offline cookbook written by Jake Archibald, it's an amazing resource that I would highly recommend taking a look at. So what service workers do at kind of a high level is they're going to cache critical assets when they're first installed. So the first time that I visit a website, my browser will say, hey, do you have a service worker? And it'll say, yes, I do. And I'll say, great, can I have it? And they'll say, yeah. Then I install it, and it says, these are the things that you're definitely going to need for this app. And when it happens, those get cached in my browser so that the next time I hit, they're already there. I don't have to download them again. We also pre-cache the non-critical assets in the background. That's that non-blocking cache. And it then acts as a proxy for all outgoing requests. And what I mean by that is when you have a service worker installed on somebody's browser, when they click something on your site that would typically request an image or the next page or a JavaScript file or whatever, the service worker is going to say, okay, give me that request first. Let me think about whether or not I have anything to solve this problem. If so, I'm not even going to make a browser or a server request. I'm just going to give you the thing that I've got. And if not, then I'll make the server. And in some cases, if you've got the right strategy, you can only have it do that once. So if it requests an image, it can say, do I have that image? No. I'll get that image, but now I have it. So you'll never load it again. You only load everything on the website once. That's great for small sites. Bigger sites, you probably don't want to cache the whole site because that would be super rude. But it also lets you skip the server entirely. So power of this, the power of using a service worker means suddenly your website can work offline. And from an app standpoint, that is really what makes the internet, like using the web, a viable alternative to native apps. You can build an app that's got a well-designed service worker that makes your entire app run offline. You now have an app. It's not a website anymore, app. That's a really killer feature. Talking about route-based code splitting, you're creating smaller bundles for specific routes. I'm going to show a diagram that makes this a little easier to understand. So let me talk through it a minute, and then we'll look at a diagram. It creates shared bundles for common code, and it allows us to only load what's really needed. And so what that looks like in practice is that on my homepage, I've got an app, like an index.html. And inside of that, maybe I've got, if we're throwing back here, I've got like jQuery in there. It's a shared dependency. But when I move to this detail view, there are going to be other things that I need. Maybe I need some carousel code to let somebody flip through images of the product. Maybe I need some features to let people zoom into things. those are only present on this detail view. And so the fragment bundle, the split bundle, is only going to show up once you load this page, which means we're now shipping multiple bundles. So there's a bundle that has something you're going to use on every page. That one you have to download. That's a critical bundle. But then you only get little chunks of stuff as you need it, which is really, really important. This will decrease the size of a bundle from 1 to 3 megabytes down to a couple hundred megabytes each, which is still a lot of JavaScript, but it's much more manageable when you're talking about loading and parsing that on a given page. When you start code splitting with Webpack, you're going to use the import like this. This is like a promise-based import so that you can get things asynchronously in the Webpack build. So it knows to only load that when that route is actually hit. In Webpack 4, you use a plugin called optimization.splitChunks. In Webpack 3, you would use the Commons Chunk plugin. And I just said Webpack 3 times, which means that Sean Larkin is now somewhere in the building. When you get into HTTP 2, I'm not going to talk a lot about this because this is definitely somewhere that, like, I know what it does, but I don't really know how it does it. I just know that it's really powerful. If you want to read really, really smart things, Yoav Weiss, who is at Akamai, he just left to go to Google, has a lot of really great content on HTTP 2. So I'd recommend checking that out. So what this does, it allows multiplex downloads. That means that instead of having a limit of 6 simultaneous resources, you can now send lots of simultaneous resources so that they don't block each other. You have the ability to do push, which means that your server, if it's configured well, can say, hey, you just requested the index.html. I know that when people request index.html, they also need bundle.js and styles.css. So I'm going to send those before you request them, which means that you get like 500 milliseconds of time back because you don't have to wait for that request to come back and parse your index.html and then make the request. That's really powerful. Asset prefetching is going to assume which routes the user will load next. So there are ways to do this programmatically. There's a library out there that's gaining a lot of steam called guess.js. Guess.js will use your analytics data and machine learning to predict what path somebody will take through your website. That's a really powerful way to do it. You can also just use common sense and say, hey, on my index page, I linked to 2 pages. Maybe I should prefetch those. You can do it, there are lots of ways to solve this problem, and you can do it at multiple scales, right? And there's trade-offs to each one. Because when you start prefetching, you're now burning somebody's mobile data because you're loading stuff in the background that they may never look at. So you want to be judicious about it. You don't want to do things that just download your whole website. That's a jerk move. But you can be kind of predictive. You're on the login screen. When you're on the login screen, you are almost inevitably going to get to the dashboard. That's your goal as a user if you login screen. So prefetching that is most likely not wasted data. You're most likely doing a good thing. So think about it like that. What are the ways that you can use prefetching to solve this problem for somebody? It loads the assets for those routes in the background, which means that your service worker or just a JavaScript file is going to say, hey, these are the things that are queued for prefetching. Let's load those. There's also a link meta tag now to do prefetching in the background, so something that's going to show up on the next load and be prefetched ahead of time. And that makes loading the next route almost instantaneous because the download has already been completed. This page just needs to open now. It's already got everything cached. On the other hand, we also want a lazy load asset. This is really important for things like images and videos. If you've got an image on the screen, you don't want that image to prevent everything else on the screen from rendering. This is especially important when you're doing like an agency website and they've got this giant, beautiful image, but that image is like 500 kilobytes. That's going to block the render of your page. So what you do instead is you wait until the page is loaded and then display everything except the images and then load those in. And it'll only request things that are in the viewport, which is a really powerful way to look at this. So if you think about a list of blog posts that's 35 items long, only the first 3 are going to be in the browser, in the viewport. So as you scroll, just load the one below as it comes into the viewport. So you're only requesting one image as it hits the viewport. And if I only scroll down 5 blog posts and click something, I didn't load the other 20 blog posts to, that I'm never going to look at. But downside to this is when you say lazy loading, it can also potentially make the page jump, right? And that would look something like this. You can see the content kind of bounces around the page as the images come in. This is one of the worst experiences as a user. When I'm on a website, if I go to a website that loads ads that bounce the content around, it's like an instant. So this isn't good. But fortunately, we can fix it, and we can fix it in a lot of different ways. So here's a solution that I rolled, which is called responsive lazy load.js. It just picks up a placeholder and does a little CSS animation to show that something's happening, and then when the image is ready, it fades in. So that's a simple way to do it. Medium does something a little more advanced. They do the blur up technique. So what they do is they take the image. Actually, I don't know how they do it. The way I've seen other people do it is they take a very small version of the image, like 30 pixels wide, and then they blow it up, and the browser does a blur for you. And then when that when the full-size image is ready, they fade it in and replace the blurred image, right? So it looks really nice. You can kind of see what's coming. You've got something visually interesting on the screen. It looks nice. You want to go really off the deep end, you can start looking at stuff like traced SVG. So what this is these pale green versions. We used a library called Skip, or SQIP. I don't know if it's actually pronounced Skip. And what SQIP will do is it will go in and look for all the lines in an image and then produce a really tiny, so this one is 4,782 bytes. So about 4.5 kilobytes to generate this kind of like mountain looking thing. And then it inlines that. So it's a non-blocking request inlined into the source attribute of the image. And then as the full-size image is loaded in, it replaces the SVG version. Super cool. It takes about as much space as the blur up technique or even like a placeholder image. So this is a really powerful way to do a really beautiful placeholder on your website. You can go further. This is also using Skip. This kind of takes the image and creates impressionist art out of it. So it redraws the image using polygons. You limit the number of polygons. You go from 1 to, I think, infinity, and it will do its best impression of your photo using the number of polygons it's been given. This looks beautiful. Like, I almost want to just take the polygon version and use it as certain images on my site. And again, this is like, they're super tiny. They're only a few thousand bytes. That's a really powerful way to eliminate some loading. You can eliminate a lot of unused code in your site as well. So you want to reduce the overall size of the code base. That should be thing number one. You'll hear people talk about performance budgets. You'll hear people talk about loading and parsing time. Loading and parsing time are both very, very important, because if you gzip something down to 20 kilobytes, but it expands up and it's like uncompressed, it's a megabyte, you still have to parse a megabyte of JavaScript. Like, the gzip size matters for transfer, the uncompressed size matters for parsing. Both of those are very important times you want to be monitoring in your app. You're going to help avoid module bloat, because as we all know, node modules can get a little out of hand in a hurry. I love this. That's my favorite. That's my desktop background. So when you get into actually using or removing unused code, there's a new library, Uglify ES. Nobody's maintaining it, so it got forked. It's called Terser now. So use Terser to remove your dead code in ES6 or ES 2015 plus projects. If you're not using ES 2015 plus, you can use Uglify.js, because that only supports pre-ES code. Enable tree shaking by using ES module. So this is a really, really powerful way to solve these problems, because if you're using named imports and exports, then your bundler can say, well, I know what you're using because you named it. So anything that's in that module that's not the named export you brought in, I'm not going to include. Very easy when you start getting into, if you can parse the AST, if you can statically analyze your code, you've got a tremendous amount of power. Unfortunately, all of that is done for us with existing tools. You can do that through Webpack, through Rollup, through Parcel, through all of them. And then analyze your bundle output. What I mean by that is use one of multiple free tools out there that visualizes what's in your bundle. And the reason that this is powerful is, like, take a look when it comes back to the top here. Come on. Bear with me. Okay, see this? This is Lodash, right? So Lodash is making up 550 kilobytes of this bundle, but I'm willing to bet they're only using like map or like, you know, what's the one like get that allows you to do multi-property getting without getting an error? That's probably the only thing they're using in the whole project, but they're loading 550 kilobytes of JavaScript. And if they're looking at this, they're going to go, hey, why are we loading 550 kilobytes of JavaScript? If they're not looking, they're just going to ship it. So take a second, look at your code, understand why you're shipping what you're shipping. Make sure that you're shipping only what you actually need to ship. And take the time to learn what that is, because it's really, you know, you might not need Bluebird anymore. You might not need, you know, most of Lodash. A lot of that stuff is now supported in the browser natively. So you may not need those tools. So look at what you're actually using it for and look at how hard it is to implement that natively, because it might be that you can trade 150 kilobytes of bundle size for like 3 lines of workaround in your code. So then we're going to get down to serving only static assets. So this is the one that I think is my most controversial opinion. I don't think that servers really need to be used at the extent that they're being used. I would say that if you're not operating some kind of enterprise API, you probably don't need server. If you're just putting stuff on the internet, you know, if you're trying to light up the box, and you want to make that box look pretty for people so that they want to, you know, move some of their numbers from their account to yours, probably don't need a server for that. You just need to be able to show them some lights on the screen. And fortunately, this is getting easier and easier to do because when you serve static assets, let's talk about the benefits and then we'll talk about the how. When you serve only static assets, you completely remove the need for server rendering, right? So you're just sending up an HTML file. We've come full circle. We're back to the GeoCities. You're eliminating an extra HTTP round trip. When you serve a static file, instead of saying, I need this website, and then the website says, great, I need this content, and then the server goes, great, here's some content, and then sends it back. Instead, what you're saying is, I need a file, and the server goes, here's your file, right? Very, very easy, very, very powerful way of getting that stuff through, and it eliminates these extra round trips. It improves your cacheability. When you are serving a static asset, you can cache that really, really hard. You can put it up in your CDN on Cloudflare, on wherever, you know, CloudFront and all those, and just cache the hell out of it because it's a static file, right? The problem is that when you start talking about server-side rendering, people tend to gloss over because for anybody who here has tried to roll their own server-side rendering? How many of you actually accomplished it? I see a couple hands up. Look at Kyle's just showing up. He's like, me. But server-side rendering is incredibly hard and it's incredibly finicky, right? Like you'll get it and then you ship something and you get a feature request and now your server-side rendering is broken and it's like, it just feels, it's very Sisyphean to do server-side rendering. But here's the thing, when you're talking about your users, loading a megabyte of blocking JavaScript is not a good experience. It feels bad. Even on a desktop, it sucks to wait 5 seconds for your site to load. We live in the 21st century, right? We've got gigabit internet. Things should be fast here. It should be instant to load a website. And it's not when you do it that way. If you do async, if you use like the skeleton loading pattern or you've got, you know, you lazy load everything, you can get something on the screen right away, but then you're showing loading spinners or skeleton components while your page loads. And you can use that cleverly. Eli Fitch has a talk on perceived performance that I would highly, highly recommend. It's an amazing talk where he talks about the psychology of getting people to believe that things aren't loading when they are loading. Wonderful. But it's still not an optimal experience. When you server-side render, there's no JavaScript required to get something on the page. It just shows up. Things are on the screen almost faster than people can perceive that things have changed. On server-side rendered sites, when you're looking at one of those pages, you navigate between them. I've seen people navigate and then like sit and look at the new page. And they're like, is it going to load? And they go, oh, this is the new page, right? It's almost so fast that it's like a bad UX. So we have to untrain people out of that, right? And so a lot of people will say, well, static files won't work for my app. there's kind of an argument that if you do anything dynamic, well, then static sites clearly don't work. Not entirely true. They will. You can do dynamic apps in static files. And I've got multiple examples to prove. Not in this slideshow, but come find me after. But I will add probably, because there are some cases where it doesn't. So let's talk a little bit about going beyond static, do pre-rendered progressive web apps. Progressive web apps are kind of, when you talk about service workers and web manifests and all that stuff, that gets bundled up in the term progressive web app, for those of you who haven't heard it. But we want to get to that point. We want to get to the point where we're not just serving static files. We want to be serving progressive web apps, but that are made from static files, right? We're moving beyond that whole thing where static file is a GeoCities page that can't do anything. No, there's not. You're sending a file that then rehydrates into a full-fledged app, right? This is a really powerful paradigm shift, and it's something that's relatively new because tools like Next.js, Nuxt, Gatsby, React Static, they're doing an excellent job of making it possible to build these really, really powerful apps, and then they just abstract away all this complexity, and you can just serve a static file. So if all of this sounds a little overwhelming, I totally understand. Like, this is really, really difficult. Performance is probably one of the hardest problems. Fortunately, because web community is awesome, we can get almost all of this performance for free. We don't actually need to do any of it. Open source is amazing. Like, it really has changed the face of the way just the world in general works, right? Because even big enterprise companies, I worked at IBM as a front-end architect. Almost everything we used, it was incredible. And that's not how it was. You know, my dad worked at Boeing back in the day, and he had to like sneak in code from other places because they were so paranoid about any code that wasn't written in-house hitting production. You had to reinvent things. I have a buddy who used to contract at the CIA, and they're still like that. You see a tool you like, you got to build it again. It's not a fun world to be in. So open source changes the world. So now I'm going to get into my pitch. I promise I'm not a corporate shill, right? So I work for Gatsby. I'm about to tell you all the reasons you should use Gatsby. But I started working for Gatsby because I was at IBM and I was pushing Gatsby so hard. I got on a call with Kyle Matthews, who's the original creator of Gatsby, and I was talking to him about how hard I was trying to push it. And he goes, "You sound kind of frustrated. Would you want to quit IBM and come work for me?" And I was like, "Yes, I absolutely would." So I'm not at Gatsby because I like desperately needed a job and that's the one I applied to. I'm at Gatsby because I liked it so much that they were like, "You should probably just come over here." So let's talk about Gatsby a little bit. So Gatsby does everything that I just talked about automatically. If you build a React app and you follow the couple things that Gatsby asks you to do to construct the Gatsby app, we will do the server-side code splitting. We will do the server-side rendering. We will do the image processing and the lazy loading and the prefetching and all of that for you so that you just get a blazing fast site right out of the gate. This is somebody who moved over to Gatsby and ran the Lighthouse audit, and they aced it with no real changes, right? They just like put together the site and it just aces the performance audit. That's a really that's not happening elsewhere in the web world. And that's one of the reasons that I'm so excited about it as a platform. It's really bridging this world between user experience and developer experience and like business needs. Because businesses need to be able to build something that is predictable and repeatable and shareable and scalable, right? Your team needs to have a component library or at least the ability to share things so that you're not duplicating the wheel across different teams. Your developers don't want to be slogging through code that is way out of date or like carefully plucking their way through a million lines of monolith code to hope that they don't break anything. They want to be working in a modern stack. They want to be like learning how to use GraphQL and React and all this stuff. And Gatsby lets you do that. And then your users don't want to wait 30 seconds for your site to load, which is one of the reasons that I was at IBM in the first place, was to help them back out some decisions that had led to 30-second page loads in certain deep parts of their UI. And so when you get into that situation, you're looking for something that kind of fits all those Venn diagrams. Where does like business needs developers' needs and users' needs all overlap. And the only thing that I found so far is Gatsby right in the middle of that Venn diagram. And so Gatsby is going to give you a framework for building React apps. Most of what you're going to do in Gatsby is just plain React. It compiles all of that down to static files to the point where if JavaScript is disabled, your Gatsby site will still load. We have a plugin that'll put the service worker and the web manifest, all the progressive web app stuff in for you. And the developer experience is ace. It's very, very good. The generated apps are unbelievably fast to the point that, like I said, sometimes our users will click to go to the next page and then they're like waiting and staring at the next page that's already loaded because it loaded faster than they could visually perceive that there was a load happening. And so that is the end of my pitch. So let's do a quick recap. If you're going to do a blazing fast app, you need to do some fine tuning. In that fine tuning, you need to do kind of a checklist here. So follow the purple pattern. If you Google the purple pattern, Addie's article is going to come up first. It's an excellent introduction with a lot of links to reading. You want to add a service worker. You want to remove all of your unused code. You want to generate static files. Get all that stuff out of the way. If you want to, you can use Gatsby to automate all of those best practices so that you can just focus on building an app. Pre-rendered progressive web apps are the future. Like, this is where we're going as a platform. We need to get to the point where that is, I mean, we are getting to the point where that's a requirement. We're just seeing that there's still kind of drop off as you know, more and more companies are either picking it up or they're just falling behind and kind of going obscure. And you're seeing that companies like the New York Times, their tech team, their dev team is outstanding. They've got some of the smartest people in the business working on these exact same problems, right? And you're seeing that from Airbnb. You're seeing that from like companies that are not really tech companies. It's not what they do, but they're investing so much in this tech because they know that that's where this is going, right? They know that this is where the future is. So progressive web apps are the future. Pre-rendered progressive web apps are my vision of the future. And in all those cases, the future is going to be extremely fast. Thank you very much for watching me talk.
Are there any questions? Right.
So obviously, based on the way you talked about it, installing the service worker doesn't like significantly add to load times, but could you talk about that a little bit more? Like, what's the hit that you're going to take for, because installing something on the browser, you know, I would think would take a second.
Yeah, when you install a service worker, the hit is like fairly negligible. The service workers themselves are only like a kilobyte or two. And so all they're doing is once they get loaded, they're kind of making the same requests that you would anyways. So unless you can make that. But if you design one that is only loading critical things, it should be almost not or close enough as makes sense.
Kind of off of that, you mentioned that Gatsby kind of takes care of the service worker and the manifest for you.
Yes.
What can you give any more details about how it does that? You know, in addition to just, you know, writing the service worker yourself.
Yeah. So what Gatsby will do is at build time, we are generating kind of like a file tree, all the things that are being built, and then we're hashing those files. So as we're building those, we're also putting them into a service worker like registry that says these are the critical files, these are the not critical files, and we cache everything. So when the service worker loads, we've pre-populated it with everything. And we also handle things like cache invalidation. If you change those files, we'll change the hash, which will mean that the service worker knows to get the news. So there are a lot of like foot guns in service workers because they're extraordinarily powerful and not super well documented. Like they're still new. So it's very easy to accidentally fork your website. Like I did that. The first time that I put a service worker in, I accidentally created a service worker that was trying to load a different service worker that was trying to load itself. So it was this like endless loop. So I had to do this really terrible hack to uninstall all service workers on my website. And I just had to leave that up for a few months because anybody who'd visited my site had that terrible hack. But yeah, so Gatsby has done a lot of work on figuring out how to do that safely and properly, and we've thrown it against a bunch of different. a bunch of different use cases so that there are inevitably going to be more bugs, but we've caught a lot of the big ones.
Second question, real quick. I'm still tripping out on you talking about the CNN website and the data that downloaded after half an hour. I'm hoping that was when you were actively browsing the site and not idle.
Nope.
No, geez.
No, I wanted to see what happened, so I opened a new site and I went to lunch, and then I came back and just took a screenshot. It was
So
horrifying.
my real question, do you have any idea what that data was?
It's mostly ad and dynamically loaded video. They cycle through ads in the sidebar, and so it was some kind of a polling thing that like added tracking code to me, I'm sure, and then did something else, and then it would like call in the next ad and cycle those through. So it just did that ad nauseum, and none of it's cached. So every time they load that next ad in the rotation, fresh. So it's a nightmare.
Any more questions?
So as someone who has never used Gatsby, I have this notion in my mind that there's this relationship with GraphQL. Can you talk a little bit about what that relationship is and what's that doing?
Yeah. So I didn't really talk about how Gatsby handles data, which is kind of worthy of its own talk. But effectively, the way that Gatsby works is that we can accept data from any backend source. So we can take it from a REST API, from a database, from a text file, a markdown file, whatever you got. And when we do that, we take all of it and we put it into a GraphQL interface that follows the relay standard. So it's a little bit daunting when you first start because it's going to have some jargon. We talk about edges and nodes and things like that. But once you get your head around it, what it means is that no matter where your data came from, you access it in exactly the same way. So when you're developing, you've got a live GraphQL server. You can open up a graphical window in your browser and just make queries for data. And when you get the data you want, you copy paste that into your React code and things just load into the pages. You don't have to use GraphQL when you're working with Gatsby. There are ways that you could build it like a regular React app and put in Axios and do all those things. You would lose a lot of the pre-rendered content, which would kind of put you at a disadvantage performance-wise. And one of the reasons that GraphQL is such a powerful thing here is that it gives us the ability to statically analyze data as well as markup, and that kind of gives we call it early binding data. So at the beginning of your build process, we'll go through your entire site, find all your GraphQL queries, run them, put them into an object, and then we can inject all that into your site. So at build time, you've got everything kind of put together, and we bundle it that way, and there's a lot of things, and that's how we can make content available offline.
Hi, I got a question for you about something like Lodash. Let's say you're only using like 3 or 4 functions and you want to get rid of it. How would you recommend integrating that into your web app?
So one of the great things about Lodash now, and I probably shouldn't have given them so much shit because they've done a great job of solving this problem. You can actually just import the function you use instead of having to import the entire Lodash library. So you can do like import Lodash/map instead of importing Lodash and then using Lodash.map. It's a really powerful way to only use stuff that you actually.
As Kyle's saying, there's also a Babel plugin as well as a Webpack plugin. So the Babel plugin will be able to integrate with how you currently do it. Say if you just import Lodash into every single file, what it'll do is it'll look at, even if you're using the Lodash FP style, it'll look at all the Lodash methods that you're using specifically, and then put those into the imports as if you're just importing like Lodash/map. And then there's additionally I think it's a Webpack plugin that will do this, but it'll actually, if you're not using particular subsets, because the way that find or map or those kind of things work is they have all these like 3 different ways that you could use it. So if you said find, an array, this thing to look for in this value, if you don't use that particular method and you just use a function to look for something, you can actually parse out and get rid of a bunch of the things that the functionality of find. So you're not even just importing just find, you're actually removing additional functionality that you don't use within find. So it can be very finicky, I will say, because if you then eventually use that particular method, then your stuff is just broken. But there are many ways that you can even augment the functionality of a specific method within Lodash to remove some of its functionality. Is there any more questions?
So you mentioned a few times that users become a little like, with how quick things load. I'm really curious if there are some anecdotes that you've heard about how developers have worked around that quick loading. Let's say if they have like one really fast app living alongside another slower app, and if there's minimal loading times, and also when is the tipping point that we're like, okay, things are just kind of loading fast and we're not having like a deliberate, 1 second spinner or something.
Yeah. So I think, the anecdotes I was giving are somewhat facetious. Like it's typically, if we're not really paying attention to what we're doing, like I'm giving a presentation and I click the thing and then I'm like talking and then I look back and I'm like waiting for it. So it's what I've found, the research that I've heard, which I'm stealing from Eli's presentation on perceived performance, is I think over about like 1,000 milliseconds, it's like a noticeable change. So that's 1 second. So what he recommends is if you're going to do a spinner, you should actually delay showing that spinner for 1 second. Because if it's after a second, then yeah, you want something to indicate that something's going to load. But before that, a premature spinner or like skeleton component can actually make it feel slower than it is. And then again, that's something you can put in your psychological bag of tricks, because if you've got an older, slower app and your newer one is like really accentuating how slow and old this one is, you might want to make this one feel slower, which would be that like hurts my heart a little bit to say. But when you're dealing with like legacy code, there's just so much stuff to fix, right? And so sometimes getting the performance perfect can take you too far in one direction when the rest of the app is still that slow. So there could be use cases for that. Did I actually answer your question? I feel like I just talked.
Are there any more questions? We'll take one more if anybody wants to ask one more. All right, we'll call it there. Thank you so much, Jason.